So the line of best fit. So when a scatter plot reveals a linear relationship, we use a line of best fit to approximate the pattern for that data. So we need to know how to draw lines of best fits. So what are the guidelines for drawing a line of best fit? So the line should follow the trend. Whatever data you see is doing positive or negative, the line you draw has to follow the trend. So follow the trend slash correlation. Number 2, the line should go through as many points as possible. Number 3, there should be an even number of points above and below the line. And number 4, the line should pass through points throughout the line, not just the ends. Okay, or the start or end. Sometimes it may not even pass through the points at the start or end. It might be more important to make sure they pass through most of the points inside the cluster of data. Okay, so for each of these graphs, make a line of best fit. So if I do the first one, I'm going to just take my straight edge here. The first one might look something like this. Okay, so again, you have following the rules here. So, 2 points below, 2 points above, most 3 lines being touched in the middle. So that's what you want to try and do. Draw a line that best fits that data. Okay. What about the next one? Next one looks a little bit strange because it looks like you have 2 sets of straight positive correlations here. Like if I drew one line like this, let's see. Not quite enjoying that. Let me try it a different way. So if I drew a line like this, okay, this is a line that could be a line of best fit. Maybe it might be better to have a line that's something like this. I mean, for a lot of this, you're just kind of estimating, you're just guessing, and that's okay. And so like a line like this has an equal number of points above and below, but it doesn't really touch any point. Okay. But you can't just draw a line with these 4 points down here and ignore these 5 up there. It wouldn't work, right? So if I drew a line like this, even, there we go. So that line might be good for these 5 points. It really fits those 5 points, but you're ignoring all these points below. Okay, so you kind of want to have an even number of points above and below. So that would make a line of best fit, something like this, more appropriate. Okay, you want to try to keep the spacing even, the space from the line to the point, above and below. Let's try and keep that as even as possible. Now you could draw a line of best fit for C like this. Okay, and what would happen is you'd be treating these 2 points out here as outliers. Right? These are special points. And you have points that are far away from the rest of your data, the rest of the other points. We call them outliers. Okay, outliers are just points that don't seem to fit the rest of the data, and sometimes data scientists, mathematicians might choose to ignore them if they can be explained, right? If they're like a special case. So here in the part D, we have a weak correlation. I can't really draw a line of best fit through that. Through this one, again, you clearly have 2 sets of rows here, like 2 sets of lines. I mean, a line between would make sense to be the line of best fit. So I can draw a line like that. If I try to draw a straight line using my tools here, let's see if it works one more time. Yeah, it's just not giving me a lot of choice to move the line, but something like that. Okay. For part F, we don't have a straight line per se, but we have something like a curve of best fit. Instead of a line of best fit. For part G, we can construct a line. Something like this would be a line of best fit. For part H, we can construct a line where we can cross as many points as we can there. That's a line of best fit. part I, it looks like we're encountering another curve of best fit, so we can draw a curve. So right here, curve of best fit. But we won't do too many things with curves in grade 9. It's mostly going to stick in through 2 lines. Okay. Part J, no discernible relationship with these cluster points. So right here, no relationship. If you look at the next one, you might notice the same thing as well. The points are all scattered throughout. I don't see a straight line anywhere or a curve, so no relationship. And here, not enough data. So not enough data to determine a relationship. Okay. So which scatter plots did your line of best fit best? So, well, if you look at G, that fit pretty good, H fit pretty good, and C fit pretty good, right? And these were really good fits, and the reason why is because the points were close together. So you can see here that the cluster points is close together. And when that happens, we can say the data is strong. So strong scatter plots. Okay. What about the ones that were really bad? Like E was really bad. I couldn't cross through any points, but I had to try and keep the number of points above and below the same. So E is a very bad one. So E, it had a clear trend, but the points were far apart. Okay, when the points are far apart, we call that a weak correlation. So strong correlations are the points that are closer together. Weak correlations are when they're farther apart. Were you unable to create a line of best fits from some of the data? For some of the curved data, some of the points that were not enough, not enough points, not enough data, and the ones that had no relationship. Okay, so moving on. Interpolation and extrapolation. So why make a line of best fit? Because we want to predict values. We want to predict values outside of our data, right? So if you let's say you collected data on selling drinks depending on the summer temperature. So what if the summer temperature reaches 30 degrees? You sell so many drinks, and your data is between 10 degrees and 30 degrees. But what if you predict the next year it might become even hotter, 40 degrees, but you have no data? Can you predict how much you're going to sell? That's why you create a line of best fit, because a line of best fit lets you predict values. So interpolation is when you predict the value inside of our data points. Extrapolation is when you predict the value outside of our data points. And when you extrapolate, you usually need to extend your line of best fit. Okay. Now you're going to do these examples on Desmos. Okay, but in case you're watching at home and you didn't get a chance to use the iPads or you're away from class, this is what we're doing. Okay. So here's a set of data here. And this data, x and y coordinates. X for the independent, y for the dependent. So temperature is my independent variable, and ice cream sales is my dependent variable. So how much money I make selling ice cream depends on how hot the temperature is. So I plot that on a scatter plot where temperature is my x-axis and the ice cream sales is my y-axis. Okay, and I have the data plotted, and it clearly looks like a positive correlation. As temperature increases, I have more sales. And the idea is you want to create a line of best fit for this data. I'll try again here, so if I can create a line. Goes through as many points as possible. Something that looks like that might work. Okay. And we can use a line of best fit to make some predictions, right? So determine the temperature when the ice cream sales is $300. So we have no individual data point for $300 here. So where's the $300 in sales? So for that, we have to do interpolation. We have to find a point on my line of best fit that can use to make some kind of estimate, approximation. Okay, so I'm going to look at where in my graph, here is $300. So I'm going to go to my line of best fit. Here's my line of best fit. I hit my line of best fit at $300. I want to look at what is the x value, what is the temperature for that to happen? Well, it's approximately 16 degrees. Right? So at approximately 16 degrees temperature, I can make $300. So temperature So approximately 16 degrees Celsius is when we have $300 in ice cream sales. Determine the ice cream sales when the temperature is 0 degrees Celsius. Well, at 0 degrees Celsius, well, we're not even on the graph here anymore. We kind of have to extend our line. And using Desmos, use Desmos to see what happens when you have a negative temperature. You might notice that the dollar values in ice cream sales goes down. It's a negative value. Okay? So you actually lose money. The temperature is too cold. No one comes out to buy ice cream. Okay. And example 2, I want you to use Desmos as well. We were doing this in class. But just to answer these 4 questions really quick, after you've done the activity, you can check your work. You describe the relationship. You're going to notice a negative correlation. Part B, identify any outliers. One point that's an outlier is 7 and 89.9. This point right here. Determine how much the person would weigh if he or she would run 5 kilometers per week. 84.5 kilograms. And finally, determine how many kilometer run per week if the person is 60 kilograms. That would be 26 kilometers per week. For that, we'd have to do a little bit of predictions. And that is impressive, 26 kilometers per week. And that is the lesson for this section.